Good morning, and thank you for joining our webinar today. I'm here with Patrick Odhner, and we are going to walk through the Revit extensions for bridge design. My name is Wendy Finch. I'm the marketing manager here at the PPI Group, and thrilled to have you all on the call today or on our presentation. Okay. Welcome, Patrick.
All right. Thank you, Wendy, very much. This is Patrick Odhner. I'm a structural advocate over at PPI here. And what I'm going to show you today is a little bit of unusual workflow, but I think it's kind of getting more and more in demand these days. And what I'm referring to is taking Revit structure and integrating it with the Civil 3D elements and taking advantage, leveraging the Civil 3D alignment and surfaces and profiles. And corridors. So I just want to preface that this is the first intro part is really going to be about linking Civil 3D, and then the rest of the presentation is going to be showing off some of Revit's visualization and interoperability between Civil 3D through its Revit extensions. And so these Revit extensions you can find on the Autodesk Exchange site, and they are Site Designer, which is kind of manipulating the surfaces, XML surfaces, and then we also have Revit Structures, and then Civil Structures, which is the extension, and we'll demonstrate and go through there and put together the whole presentation through those. So right here, I only have a couple slides here, and I just wanted to show you the outcome of what we're going to do here. And pretty much, we're going to start from scratch and perform this through Revit extensions and Civil 3D. And basically, just a quick terminology on bridge work here. These are the piers, and I can zoom in here. And sorry for maybe resolution is a little low there, but here are the bends, and you can actually see that extending out there, and then abutments here. So girders, pads, support pads, and then you have the decking, and then we also have some adaptive components here that we're actually going to put in there, and I'll talk a little bit about that. Very neat topic, kind of a free-form, fluid topic that we can use and take advantage in Revit. And then also there is a railing on here that I'm going to be placing on and attaching onto the work plan of the deck there. So I think you'll find it pretty entertaining, so just enjoy, and I'm just going to go through this. So here is the one rendering, and then I wanted to show you this. This is the power of Revit here. You can do snapshots of any point on your bridge, and this is the perspective shot. And I'm right on, basically my perspective is on the sidewalk, and looking through here I can actually see the extension of the vents and the deck, and then my adaptive component here that we're going to integrate. So let's get into Civil 3D here. And I'm performing these two with 2017. And so I highly recommend, if you're going to do something like this, integrating one program from another from the collections, you would want to actually stick with the same build and same version to avoid a lot of conflicts later on down the road. So I'm going to open up a surface, and it also is an alignment, and basically the framework of what we're going to be starting with here. And this was provided by our Kevin Clausen. Thank you very much, Kevin. He actually is our Civil 3D expert here, and he provided this corridor with the roadway here, and we also have some sloping on the daylighting here, referred to as daylighting. And let me zoom out here a little bit, and I'm going to pull this. Collapse this. Oops. Basically, I'm trying to collapse this the webinar screen here. Is there a
Oh.
little key here, Wendy? I can.
This here?
Right.
Sorry about that. Hit that little arrow.
Oh, there.
Get his menu bar out of the way so we
Thank you.
can
It's a
see his screen.
New interface for me. Sorry. Okay, so I'm going to go in here and actually go into a 3D view here and just give you an idea of what we're working with. This is our XML surface here, and then we also have a corridor, main corridor running through here, and two alignments. One is a main alignment, the primary one, which our bridge will be set upon, and then this underneath is actually a local. And this is actually the criteria, starting of the criteria of what we're going to design our bridge around here. And so this, I'm going to go into a top view and pull it back to Wireframe. And the components of the Civil 3D file, now this is the requirements that you need in this Civil 3D environment to make it work with Revit. And you know, I kind of found out this the hard way, so that's why I'm presenting this, to save you guys a lot of time and effort. So first of all, you need a profile, and you need basically, it shows your lifts here and your roadway, a section through your roadway here, curb and gutter and sidewalk. And then you also have the slopes. So this is all parametric in Civil 3D. And you also have your XML surface here and your alignment. And so we're going to be leveraging that in Revit and placing our bridge right between these 2 points. So this is real geo-referenced coordinates here. So we're also going to be performing shared coordinates in Revit, which is a very powerful tool to be able to talk to Civil 3D and relate those coordinates back from the real world. So here we have the alignment. I just wanted to go over the main alignment here. Our control point for the bridge is going to be station 10 here. We are going actually to start this elevation of the roadway at 290.43, and these are real surface numbers from Civil 3D. And then we also have this corridor running through here, a local corridor underneath the overpass. And our goal is to put our supports adjacent to these so they're not encroaching in any type of easement or right-of-way there. So, so let's get started here with the Civil 3D part. And this is really slick, actually. This is an extension in Civil 3D. And by the way, you need to have Civil 3D open and Revit open to perform this. And so right in here, I'm going to go to Bridge Modeler. This is an extension you can download. And we've got these classes of bridges or types, box girder, concrete slab, or precast. And we're going to use the concrete slab with girders bridge. And so if I click in there, it actually recognizes, you get some information here, user defined that you have to put in here. It needs a corridor to rest upon. And I'm going to pick my main corridor, which is Road 1, and that is the one running through along here. And our alignment, Road 1, that's good. And then our region, and that region is actually set up in Civil 3D right in here. And we're going to take advantage of that stationing region. And right in here, it's approximately 950 by 1050. And so that is our baseline. That's our control points here. Our stationing, that's what we're going to go by. And we're going to hit OK. And here we have this. This is real time, folks. So I'll actually be going into another file due to the regenning of the family elements. It would just take longer than this session. So there will be a point where I will switch files. But right now we're actually in this file. And I wanted to go over this viewer here. This is kind of neat. I'm going to expand this out a little bit. This is a dynamic viewer here. It actually reflects the stationing that your abutments, those red hashes, ticks are abutments, and then you also have this green, which is your pier support. And this is all automated at this point. Here we can actually start adding in some user-defined things. So I'm going to go down and leave this stationing the way it is for our abutments and go down to our piers here. And I'm going to add another pier, and you can see right there it's adding another support up there. And so here I'm going to click down Arrange, Now this is a very rudimentary figure. You'll get a lot more information in Civil 3D, but this, through the extension, this is all we pretty much need for our Revit model. So here we have the arrangement, and here you can actually type in the actual stationing in here. And I know that our corridor needs a little bit more breathing room here, so we're going to put in 975 station. And you can see right away it dynamically moved up there. And you can hover your cursor over there and actually get stationing, increment stationing up there too. And then down there we're going to go with a 1025 stationing. And right there we have a little more room there for our corridor. Skew angle. So there's some of these things I'm going to take care of in Civil 3D. So if I go down the line here, you have all these components that you can actually go in here and define. And so we'll be actually doing some of this stuff in Revit. And so by that time in Revit, all the families will be created and we'll be actually making adjustments to the Revit family components. And so I just wanted to give you a quick overview of what this interface looks like. Pretty easy going interface, pretty easy to figure out. Basically, abutments here, I mean, if I go up here, I can actually change wing wall abutments, and then you see you have some information in here you can put in on the angle of the retaining walls there. So I am going to just go through here, and it looks like everything is in the correct coordinate system here. So I'm going to hit OK. And you can see creating bridge elements. It's running through here pretty quickly. And what it puts down here, and let me just show you, this is a 32-foot roadway here. This is just a placeholder, kind of a generic girder-style bridge. You can see the girders laid out with the piers here and the bents, abutments. And so it's conforming to our region. And we'll also put in Revit 290.43, which is the top of our lift, and we'll actually coordinate that together and have these things synthesize. So, so let's save this, and this, remember, has to be open, Civil 3D, and I'm going to go into Revit, and I'm going to start a new structural template. And here we are. So this is familiar. Anybody in Revit in the structures or architecture is going, or MEP is going to recognize the templates here. So templates, you get a few views. And so in the structural template, we have a site view. And I'm going to click in there. Site view is really nice because your view range is expanded. We're going to go over here and expand it even more to give it a little more room here. I'm going to say top unlimited. I know my surface is at 290, my top of my lift, so I do want this to be unlimited. And remember, when you're in Revit in this view, or a plan view, you're always looking down, so make sure this cut plane is above your surface. So if you do have slicing issues in there that look strange, it's probably due to your view range here. So I'm also going to change this to unlimited, and for my view depth, unlimited, and hit OK. And these elevation markers, you can actually delete these. I'm going to leave just one of these for relationship reasons when I bring in the Civil 3D elements. And so here I have my survey point and my project base point, and this is typical. You can actually turn those on through your visibility graphics here. And this is all covered under the site category, and so this is the project base point and survey base point. Project base point is internal. This is an internal method that Revit uses to keep track of coordinates. When you start collaborating, though, shared coordinates is preferred, and this survey point is what you're looking for at that point. So that is more of a georeference point there relating back to the Civil 3D world. And so to start this up, I'm going to perform a quick shared coordinates here, and that would be going over to Manage and Coordinates. And you can acquire or push coordinates to a linked file. We're going to actually just specify a coordinate at this point. And even though they're over coincident on top of each other, there's only one point to choose that's on the shared coordinate point here. And I'm going to place in, if I go back to my Civil 3D model, I have this control point for my bridge. It's always great to establish this from the source. That way you don't run into any inconsistencies, problems in Revit. So you got to be dialed in pretty tight on that coordinate system. So right here, I'm going to type in 2195.75, and this is going to be, Revit is going to be in fractional inch feet here. That's okay. We can leave that for this application. And then east-west, I have a 2984.59. And then my elevation, we can actually throw that in there right now, 290.43. And later on, you'll actually find out, do you want your project related as far as your datum elements? Do you want it related back to, the survey point, or do you want it related back to the internal elements here? So I'm going to leave this as is, and we're going to change this angle later on in Revit because Revit likes to have everything 90 degrees here. So I'm going to leave that there. So you can see my survey point shot off, and I'm left with this internal. It's transformation here, and you can see the east-west elevation in the north is all set up here, and your shared coordinates site is up there. And so now we're going to link in the Civil 3D file, and remember this has to be open here. So insert. I'm going over to link CAD, and we're going to bring in this overpass. And the only thing we're going to change down here that's special is make sure this sometimes defaults to center origin. We want this by shared coordinates. And one thing before I do that, I want to go into Civil 3D and save this file. And now we're going to link in the Civil 3D. And so this is going to fall, our stationing bridge control point is going to fall right on our project internal here. So this is also a lot of information, and just a forewarning, try to keep your surface as minimal as possible for your site, because all that information, and you can clip things and do things like that, delineate work sets in Revit, but it's always better to go back to that source, fix it up, just like if you were to bring in a section detail from AutoCAD into Revit, you'd want to clean up those layers, clean up everything as possible, and then bring it in here. So here's our dialog. And by the way, if we do crash, which it does happen sometimes, I will open up a new file and we will continue with the method here. So this project and link do not share the same coordinate system. The link's world coordinates will be aligned. And so we're going to hit OK on that. That's good. And so that means we are linked with the coordinate system. And our bridge control point is sitting right in the centroid mass there. And here we have a whole linked file. It's the same file, and that's the beauty of it. Later on, we're going to be exporting this information back into Revit. So it's fully integrated and linked. It's a bidirectional link there. So you really are taking advantage, both parties, Civil 3D and Revit, are taking advantage of their great design that's been implemented in them. So what we have here, you can see the stationing, and at this point we're going to manipulate this bridge, and you can see, don't get worried, even though this roadway is not aligning up, when we start importing families into Revit, they will, and then when we have that bidirectional link, we go back to Civil 3D, all these components will be updated for solids from the Revit world here. So here I'm going to go up here and leverage the extensions. So here I have Site Designer. We'll use that in a little bit. Extensions, and you'll find this under Civil Structures. And first of all, what we need to do is integrate with AutoCAD Civil 3D. So basically, Revit pretty much, it's very interdependent on Civil 3D on this information. You cannot perform this method with just Revit. So we're going to turn off our local, and we're going to make sure that bridge in Revit is on the RD1 corridor. And we can turn off some of these subcomponents here of the composite surface. And then we've also got this stationing. So it's kind of a double check on when you bring this Civil 3D Elements in here, you can check the stationing right in there. So it looks good, and I'm going to hit OK on that. And here we're importing all that, some of that information and turning them into families here. And we'll complete the process by going up there and running this, running civil structures in Revit. So here we have a road configuration, horizontal alignment, vertical profile. So some of these things, all civil, here terminology, but basically it's integrating, and you can see the bridge component here, and the stationing is correct in Revit, so 1050 by 950. We have our center of mass there, and we're also going to this corridor, road 1, 950. So we're going to hit OK on that. And this is intersection warning. Another dialog to create the imported bridge, run bridge definition. So it's just telling you you need to run the bridge definition one more time to complete the process. So right in here, we're going to go down, and this is our tool right here. This will get us right to that interface that looks very similar to the one in Civil 3D. It kind of emulates it. There are a few more options to change the structural components, and you'll see right here we have decks. We can also go in here and change the roadway. You've got these, looking very similar. The barriers, we can go, horizontals, or we can do vertical, sloped. Girder sets. You've got all this criteria designation in there. The girder type, easy enough to change. And remember, you don't have to place an in-family component here. This is all being developed and taking care of it for you through this extension. Abutment piers. So at this point, we can fix all this criteria and make it so, to your design intent here. So what I'm going to do here is hit OK, and it's loading up all that information, all the families, and this is where it can be a little bit time consuming. This is where I'm going to go. I just wanted to show you kind of a better proportioned bridge and relating back to the roadway after dialog is done here. So right now it's just processing all this solids and families. And you'll notice when you get all these families in here, they don't have any parameters attached to them, not much at least. So you have the opportunity to go in there and add your own parameters and flex that and add even more powerful parametric ability to it. So it looks like it's cruising along here. And it's absolutely amazing, actually, how fast this moves forward with all this. So we're getting kind of a preview here, and so there we go. So here we go. It's taking care of it for us. Our roadway, basically, it follows. And that's why this is a necessity. You have to have a corridor in here. You can't just go into Revit massing tools and change the elevations and things like that on the topo. This bridge needs something solid to attach to, and that would be the corridor here. And so here I'm going to close this down. And right here I'm getting the save coordinates back to the link. So there's one thing here we need to do, and that would be closing Civil 3D. So the one thing, though, before we close that, I wanted to show you, I'm going to go into a 3D view here. And this is in Wireframe. And you can see it actually took the information, corridor, and everything and placed it you can actually see this bridge. I can put it in shaded mode so you can kind of, so the definitions more. It created families here. These are just regular families. This pier actually probably has the most parameters attached to it. You can change that, and that's built in. So you have this, the piers are actually just kind of going past the corridor there, so that's a good sign. So if you wanted this information back into Civil 3D, you would go through the extension, and there's another category here. It's called Exporting Revit Elements to AutoCAD Civil 3D. And so if I do that, you're going to get this dialog, and Civil 3D Extension is going to use this shared coordinates. You can also type in here you know, different values for source points and things like that. So I'm going to use the shared. And it is processing this information. And remember, when you go into Civil 3D, it's going to be solids. So we get some information on some of the surfaces that need to be updated here. So let me go back in here. And I think what I'm going to do here, right now you can see it's actually not updating, so I'm going to close this. And I'm going to go back into Revit and actually go here. And I'm going to try this one more time. I won't spend too much time on this. So I'm going to open that one more time here. And integrate. So this is where you actually have to select the elements. And I just selected these solids here. I'm going to filter that out, and analytical generic mass, that looks all good. And extensions, civil, and export. And let's see if we can get this thing working here. Oh, apparently it's not updating, so I'll just move on here. But essentially, basically what's happening is when you update the Revit model, this information, actually you'll see all the Revit objects come back into Civil 3D here. And so that's kind of one of the leveraging powers that you have, so everybody's on the same page with bridge design and civil design. So I'm going to close this, and if we have time, I'll actually, you know, run through that one more time. But here I'm going to focus on Revit here. So I'm going to go back to the top view. We've got our bridge in here, and right here I am going to close this one and open up a new file here with the adjustments, and this happens to be on my recents. So essentially what I did here is extended the deck here, and I'm going to go back to a 3D view so you can kind of see clarity here. And I've also extended the deck. You can see the vents are extended out a little bit, and I also put in an in-place family here, just kind of a simple column to support those decks for our adaptive component. And so I'm going to turn it here. And if we click this in the wireframe, you can kind of see the framework of what's going on. All the girders are intact and everything like that. So you get a lot of information in just a few minutes here. So really, really nice. So right here I'm going to go into shaded and into the site view. And right here I have, remember the opportunity I had, if I click on this component here, you can see we can set Revit to, I actually set it to 315 degrees here over an angle to true north. So any view that you actually go into, you have this opportunity of going over here. Once you set that shared coordinate, you can go back into Project North and go back to the original orientation. So right here, to place our components, we're going to go back to True North. And let's take a look at this on a profile level, and I'm going to look at the section. And here we have this. Basically, you have the profiles, you have the bridge here, and it looks like the decking, the barriers is all there, and then I can actually do a transverse running through here, and you can see all the girders, barriers, and then I extended that deck out here. And so there we go. So I'm going to save this. And we're going to start, one thing I wanted to show you is Site Designer. It's just a real quick thing. You can do a lot more with Site Designer, and I am going to delete that XML surface here. And so right here now I have the bridge on its own, and you can kind of see a better view of what's going on here. I put in some hammerhead piers here with the wing wall abutments, and this is all from the user interface here. So you can get some real nice visualization here. And so now to bring in the same land XML file that Civil 3D is using, we're going to use this Site Designer. And I recommend Site Designer if you're going to do any tweaks to the surface or anything like that. Don't use Revit. It actually goes off the Delancey method, triangulation, and it's a very simple method, very simplistic. It's basically just elevations up and down, and your points are going with it, and your tangent lines, things like that. Civil 3D has a much more advanced method of creating, manipulating surfaces, and this kind of goes along with that workflow here. So you can start adding features, retaining walls, things like that. We're going to just import a land XML file, and here it's very simple. We're going to use the survey point, and we're going to click on here. I have one created there. This is the same one that the Civil 3D project is using. So that's the beauty of it. You're not able to bring in land XML if you do not have Site Designer. So this is kind of one of the advantages of having this in here. It is tested, these two, so they don't interfere with any other functionality in Revit and things like that. So that's important to know too. So add a new topo surface. We're going to use that composite FG. And what we have here, I'm going to actually do that one more time, and we're going to go into the site, change this to Project North, and bring in this XML file, and hopefully this will be oriented correctly here. Well, looks like it is rotated, so I'm going to go back to our surface that was actually working here. Here we go. So this is actually essentially, since I changed the shared coordinate system, this XML file is actually coming in twisted. So this is actually the one we're going to look at here. So that's kind of the workflow of bringing in and marrying these two programs together. So and also you can see here, I can, cut, you can actually get surface information. Here, it's going to require some regrading here, but essentially a very powerful visualization feature to have, especially when you're, kind of doing the preliminaries, the proof of design and things like that, all those steps that you have to do in bridge design. And here you can also add piles and things like that. So now we're going to move ahead and focus our attention to putting on an adaptive component. So this is kind of a cool thing. I wanted to add this because a lot of people don't really take advantage of this too often, but it really is can really show off your project with some pretty nice architectural features, and really you're not, it doesn't require that much time to actually create one. So I'm going to open this one of these adaptive components. This environment, I just want to tell you, this environment in Revit is a very different environment. It's not the same as our creating elements through the type selector and things like that. It's a lot conceptual, but I'm going to just go through some of this pretty quickly, and it's a very basic adaptive component here. And so I'll show you the mechanics of what's going to happen. So here, this is our pattern, and we always have to start with a template. And so here, I started with the rectangular, this is actually a curtain-based organic or curtain-based adaptive component template. And there's several others. There's generic, and there's also conceptual mass. And so here we're going to be dealing with these curtain walls. And the cool thing about this, you get different patterns for this grid. So what's going to happen is I'm going to keep this, depending on what design you want, you can actually pick one of these templates in here already predefined in Revit and have your adaptive component. These are all solid objects attached, very much like a family, is a family. And so what happens here is what's controlling this framework are these adaptive points. And this is kind of the whole thing behind the magic here. So what you want to do, though, since this environment is everything has to be connected and linked back to these points. So notice my pattern is taking up one grid here. And so you can modify these elements. These highlights that you see here are reference lines, and you need to place those reference lines to actually link on your solids. And so you also have the point there. This is an adaptive point over in our properties, and I'm going to move this, adjust this. And so this is a way of testing your adaptive component. If this point or these elements actually don't coincide or link with this point, then you have a problem. So it's very particular on where these points actually go into. So this is a good measure if you wanted to test your adaptive component, and there's plenty of information for you guys to start doing some of this stuff. So I'm going to move this actually down, and you can see proportionally this is actually below that XY grid there. So the Z factor is below there, and I can go over here, test this one out. It's always good to test these out, so it's it as well with that curtain wall. And we can also test these out. So just remember the higher, more acute the angle here, Revit and even the geometry, it's just not going to be able to calculate. So keep these angles pretty modest if you can, actually. And so now that I've kind of tested this out, I'm going to click on this grid here, and I'm going to say reset points back to grid. And so here I have these compaction going right back to my template here. So now that I've kind of showed you a little bit of this, this is the component that's going to be populated and replicated on our curtain wall here, which is going to be placed on our bridge. And I'm going to go to View and switch windows, and I'm going to go over to this grid. And this is the file that's going to host our adaptive. And we could do all sorts of splines and curvy lines and all that stuff, but I just wanted to show you the mechanics and also some of the method and the purpose of adaptive. So here I clicked in here, and I'm going to, this is all this is an extruded line here. I'm going to click Divide Surface, and here you have the start of our pattern. And here you can actually adjust this with the U grid and the V grid here. So I'm going to actually add 6 to that, so it's a little more proportional. And all those Fibonacci numbers out there, you cannot add that perfect golden ratio in here. So you're going to have to deal with this. Maybe I guess grab in there and add maybe something close like a 8 to 12. So we have something like that, so it's aesthetically pleasing. And now what we're going to do is save this. And I have here a 94 foot 9 3/4. So this environment, you're able to actually put on dimensions, start drawing things. It's extruding and things like that. It's how things are attached in this environment that are a little bit different in your workflow. And so right here, I'm going to load in the open component. Oops. Actually wanted to be in, notice I was in the grid file. I want to actually be in the component file and load this into curtain file grid here. I'm going to override existing with parameters. And go back here, go to my grid, and so it should be loaded in here, and all you have to do to place this information, get that component on here, is go over and select your curtain panel here, and then go into your patterns here, and since I've loaded this in, this is going to come in right in your type selector here. So I'm going to say real rectangular. And so what we have here is it's populated all those components within this curtain panel here. And from this point, we have something we can bring into the conventional Revit world here and add some, spice it up a little bit. So right here, I just wanted to show, I won't go over creating parameters in the time we have here, but let me go back to view, and I'm going to go and just show you what is possible with parameters here. Notice I have these, I have a tapered, I'm going to show you kind of a rendering style here. I have kind of a component in here, and then these are all glass frames here with a kind of a teak wood frame in here, and I just wanted to color that to differentiate that to show you. But here, if I go into my select on here, and you can see this is a solid. You can also select the materials, and so right in our type properties here, I actually set up 2 parameters for glass and teak. I've also, oops, spelled that wrong, also did a parameter for the sphere. So the size of the sphere is, I did a little quick formula over here. The smaller radius for the sphere, smaller spheres are 1.5, and then the 2 are on the larger spheres. So you can get really creative in here, and those are, you can schedule the powers from that and come up with some not just conceptual things, but parameters will allow adaptive components to bring those components into the world so you can actually build it. And so it's not just a pretty picture anymore. So parameters will add that power. And so I'm going to close this file. I might as well leave that open. I'm going to go back in here into my grid file and make sure everything is all set up so I can bring it in. And I'm going to leave this the way it is. I'll save this. And I'm bringing this curtain panel, kind of the screen here, into our Revit project. So if I go view, I'm going to go back to our Revit environment here. If I go to level 1, I'm going to bring this to fine and shaded. And here I can bring in a component. And so first thing I want to do is I want to go back to view, and I'm going to load this right back into the project here. And you have this load in the project. Very useful thing to have. That way you can keep track of what's being loaded. We're going to bring this into bridge region phase. And I'm going to overwrite. Let's see, we'll try to get by that one. And going back to regen here. And now I'm going to bring in, we should have the updated component. I'm going to say place component. And here we have our adaptive component coming in here. So I've already set this up so I know the length that I wanted. And so right here, it's asking for a reference plane. And so, you know, roadway 1, I have a reference bend, or I can actually pick and I picked the roadway here, and I'm going to just put it on the midsection here. And if I go to a 3D view, turn it over here. And so sometimes you may not be able to see your adaptive. That's just because you need to go into VG and turn on some of your visibility of materials in here. And sometimes the mass actually is not on. And so here I have this you know, nice feature here. Normally you could also do surface patterns in here to get that look that you need, but very powerful to add on here. And so we could actually take it a step further and get some real scheduling properties off here. The next thing I'm going to do to kind of dress up this bridge a little bit is to put on a railing. And I'm going to go back to level 1 here. So here I have my barrier. And the cool thing about the Revit 2017, I really should have been done a long time ago, but it's great they did it now. Railing can actually be used on all sorts of components now. You can use it on roofs, retaining walls. And my colleague Curt Egli did a great session on new features on architecture in Revit 2017 you should check out. So here we're going to do just a quick demonstration of sketch path. And I need to access a work plane. So I'm going to do this one more time. Sketch path. Let's save this. So let's try a different work plane here. I'm going to try site. And right here it's asking me to sketch a path of the railing here. So I'm going to use this. If you can't find your railing, you can always do transfer project standards from another project. I actually am using this glass panel railing by default. And basically I'm going to go down here and place this and sketch this out across the bridge here. So when I check that and go to a 3D view, you're starting to get some pretty nice features here. I'm going to grab the railing and do kind of a quick rotation here. And so really you're kind of keeping the fidelity of Civil 3D surfaces, and you're also coinciding with the Civil 3D alignments, and you're also able to go in here and add some pretty nice Revit features, above ground features here. And from this point we can start doing our renderings and save these renderings, and basically this is the final output of today's demonstration. I did not mirror the other side just for time constraints, and so that is pretty much wraps it up. So I really appreciate it. Thank you very much. I hope you can use this workflow in your future projects.
We thank you for attending, and we look forward to seeing you on our next one. Patrick, thanks so much. It's been informative and a lot of fun.
Oh, great. Thanks. Thank you, folks.